Hey everybody, this is Scott Grammer and I am the Old Audio Guy, and welcome to the third video in the series on the cheap Chinese amplifier refit. For those of you keeping score at home, this should have been the fourth video. However, last week was Easter and I was visiting my sister and did not make a full-fledged video on this subject, so that makes this one number 3. So let's start with just a picture of the amplifier as it stands right now. It is very close to being finished. You can see there's a couple of switches that were not on it to start with, one in front in between the meters and one on the top deck in between the meters, and we'll talk about those in a minute. And here is a photo of the underside of the chassis showing the wiring as it stands now. I will be publishing a schematic of the whole thing, but not just yet because I'm not 100% sure that this is how it's going to be. I have made quite a number of changes to the amplifier. I've changed the way the driver circuit works. I've changed the power supply. I did add some filter capacitance to the lower voltage supply that drives the driver stage and the input stage. And the biggest change I made to the power supply was a very much improved ground connection between the main filter caps and the star ground of the amp chassis. I noticed during listening tests that the amplifier had an objectionable level of hum, especially when you turn the volume all the way up. The hum was coming from the input stage and there was too much ripple on its power supply, and so I started by adding that filter capacitance and adding a second stage of filtering to that supply's circuitry. But the real source of the ripple actually turned out to be current across the ground wire between the filter capacitors and the star ground, which is where the center tap of the power transformer is connected. This current was developing a voltage across the wire, and that was because the wire that I used was simply too thin. So I changed that wire out for one that was 6 times as heavy, and the noise essentially abated completely. It's not totally gone. It's nearly impossible to completely get rid of the hum from a single-ended Class A amplifier that has no negative feedback. But at this point, it's low enough that, without giving an exact figure for it, which I'll do later, it's low enough that I can connect it to my JBL L80Ts, turn the volume all the way up, and walk up and stand in front of the speaker, and I do not hear any hum whatsoever. So let's talk about those switches. The one on the front here switches the VU meters between their normal duty, which is simply giving you a visual indication of the output and looking really neat when you run the amplifier, to showing the bias level of the output tubes. Most single-ended Class A tube amps have fixed bias. There is no adjustment for the bias, which is very convenient, but the downside to it is that the circuitry that makes that happen costs you some output power, and there is not a lot of output power in these amplifiers to throw away. So I decided this amp would actually have adjustable bias, and here I'll show you a couple of pictures showing the bias adjustment controls, which are behind and to the side of each of the output tubes. And the way this works is you simply turn the amplifier on after connecting speakers to it. You should never ever turn on a tube amp without speakers connected. You turn the amplifier on and turn the bias controls all the way down, counterclockwise. Let the amp heat up for about 3 minutes, and then flip that switch in between the meters up, and you'll see that the meters are indicating some level of current. And all you have to do is turn those two knobs, and you'll have to go back and forth because they do interact a little bit, and adjust them so that both meters read 0 on their VU meter scales. And you're done. Flip the switch back down and play you some music. You can do this anytime you want to change the output tubes, so you can roll tubes and make sure that each time you do, they're biased correctly, and you get the best results from those tubes. By the way, this amplifier can use 6L6 GCs, which is what is in it right now. It can use KT66s, or it can use 5881s. Now you can use EL34s in it. However, as I said in an earlier video, the output transformers are not the correct impedance for EL34s, and so you're going to be making a compromise there, but if you want to try it, it will not hurt anything. Go for it. So there were some other changes made to the topology of the amplifier. For instance, I removed the cathode bypass capacitors on the driver stage. This gave up a little bit of gain in return for a little more linearity, and since I didn't need the gain, I decided to opt for the linearity, which is to say to opt for lower distortion. So there were some other minor changes which will be reflected in the final schematics when I do publish those. And for right now, that's kind of all I've got to say about it. I can tell you that it's a good sounding amplifier. I'm happy with it so far. It sounds way better than it did as it was originally built. And who knows, maybe you'll get to hear it sometime. All right, that's enough for today. I'll talk to you later. Bye-bye.